So your game should be working so that when you move your mouse, your player moves back and forth. Enemies are appearing randomly at the top of our screen and then traveling downward. The next thing we need to make is a bullet for our player to shoot into our enemies and our enemies to then disappear or explode. So we'll go into our code here. To make sure you have the right code, you can always go to your class name here and click on that little pencil. This is a helpful tip. So then you know you're always editing the correct version of your code if you're changing versions, which is a good thing to do. Every time you make major changes, and actually before you make your major changes, always go to File, Save As, and you can save your game with a new version number. And you can either open up your old version and keep changing it, or you go to your flaw and you change your connecting file that connects to your flaw to your AS file. You change the name of that. And when you do that, you'll also have to change the name of your class to match that new name and the name of your constructor. So just a few changes, but it'll save you in the long run when you're playing around with your code. You'll always have a backup version, working version, to go back to. Alright, so here we have our code. Here's our instance variables at the top of our class. And since we want to make a vector of bullets, actually, let's go back here to our flaw. First thing first, we got to make a bullet object. So I've already created a bullet object that looks like this, and I just used my drawing tools. So I just used my pen tool to kind of draw just a dummy bullet. You can get a better bullet later. You can just draw a circle for now, even if you don't want to go that in depth. Just use your circle tool and draw a bullet. Change the instance is a very easy thing to do, and you don't have to change your code at all. So we'll go into that in another video. But you select your bullet and you press F8 or right click and say convert to symbol if you're on a Mac. Convert your symbol to a bullet. I already have a bullet, so I'm going to name it bullet 2. And remember to click export for ActionScript so that we can create bullets in our code. It'll then make a class for you called the bullet2 class, which we will go into later. And then you press OK. It says it's going to make a class path for us, and we say alright, and there's our bullet 2. Now we're going to click on this instance of our bullet, and delete it from the stage because we're going to add our bullets programmatically through our programming code. So we'll go to our avoider game 3, or your avoider game AS file. Remember to click on the right AS file, you click on that little pencil. Okay. So now we need to make a vector of bullets. Remember what a vector is. A vector is a collection of objects all of the same type that we can name one name. So I've named my bullets vector bullets. We've made it a private instance variable. That's a good programming practice to do. We've called it a var. We named it bullets. And we say bullets is going to be of type vector. And in that vector we're going to hold bullet objects. This is our declaration of our variable, our bullets variable. Now we'll need to instantiate that bullets variable. So here's where we instantiate our bullets variable. We say bullets is assigned the value of a new vector of bullets. This is our vector bullet constructor we're calling. Constructs our bullets in RAM for us. Alright, and then we're going to write a new method. So we're going to listen for an event in our program. Every time the user clicks his mouse, we're going to shoot a bullet. So we're going to have a mouse event that we're listening for. So we'll add to our stage an event listener. So here's our stage object who calls the addEventListener function. The addEventListener function takes in two arguments. The first argument is what we're listening for. We're listening for the mouse event class. We know it's a class name because it has a capital letter. And then the dot operator, and then so we know this click variable is part of the mouse event class. We know it's a variable because there are no parentheses here. And it's all in caps. And that signals to us that it's a constant variable. And then we have our second argument, which is the function that is called when this event is fired. And our function we are going to call shoot, because we're shooting a bullet. You can name it whatever you want. Remember, your function name can be whatever you'd like it to be. But you should name it something that it's doing, so then your code is more readable. Here's our shoot function. We've defined our function outside of any other function. And remember that you can label the ends of your curly brackets here. So then you make sure that you create your functions outside of any other function. Bracket placement is important. And when you write nice, neat code, it is easier to debug and read. So remember to try to indent your code correctly. Proper indentation rules are after every curly bracket you indent 4 spaces. Alright, so here's our public function shoot. Okay, we've named it shoot. It takes in one parameter, and it has to take this parameter because it is an event listener, and all event listener functions have to have a parameter type of event that it's listening for, in this case a mouse event. Then we have our colon and we have our return type. This function will not return anything, so it's type void. Remember that a function can return one thing or nothing, and this function returns nothing. So here's what we want our function to do. We want it to create a new bullet, put that bullet into our bullet vector, and then add that bullet to the screen. Bullet, so we say var. We name our bullet with a lowercase b. It's a variable name. It's of type bullet with an uppercase b because that's our class name. And it's assigned the value of new bullet. And here's our constructor, and look at how our constructor looks. We want this bullet to appear where our player is, so when they shoot it looks like it's coming from the player. So we need to make our bullet appear at the x and y value of our player. Let's make our constructor so that we can give it the x and y value of our player, and our bullet will appear at that x and y, or have that x and y value. We've created a new constructor, so let's create this new constructor that takes in the x value and the y value and sets the bullet's x and y to what we send it. To do that, we're going to actually edit our bullet class. So remember that bullet we made in our flaw file? Right-click on it, go to its properties, and click on the little pencil icon next to its class name. We're going to edit that bullet class that it made automatically for us. We say, okay, we'll open it in Flash Professional. And here's our bullet class. Now I've already edited, but this is how we're going to edit this bullet class. Notice that this bullet class already extends from its movie clip because it is a movie clip object. Here's our constructor. Constructors are special functions. They're the only functions that will be capitalized because they have the same name as the class. And so constructors are always the functions that are capitalized. Alright, our constructor, we're going to change it so it takes in 2 parameters. You can name these parameters whatever you want, but it's good to name them names of what they represent. This parameter is going to represent where we're going to put the x value of the bullet when it appears, or when it's first created. This value will be the value of the y value of where our bullet will be on the screen when it's created. They're both of type number, so 2 parameters. This x value comes from the bullet object that's calling the constructor. So this x value belongs to the object that this constructor is creating. Remember that constructors are special functions that create objects for us. So we'll assign the x value of the object that it created what we passed in as the parameter. So the start x, our x value is now equal to what we passed in. We do the same for the y value of our bullet object. It's given the value that we're passed in as the second parameter. We're also going to need this function here. We might as well write it since we're here in our class. Notice that's a function outside of any other function. And if you get confused with the ending curly brackets, remember to label them. Okay, so this function here, I bet you can already tell what it does. And you can tell that because we named it a good name. Remember to name your functions what they do. We call this function move up a bit. And it's going to make our bullets move up a bit. Now, if you decide to put your curly brackets on a line by themselves, then they should all be on a line by themselves. But if you decide to follow the standard and put your curly bracket on the same line as the function definition, then they should all follow that rule. Notice that they all follow that rule. Alright, so this function here takes our old y value, it subtracts 7.5, so it makes our bullet move up 7.5 pixels on the screen every time that this function is called. And it sets that new y value, or that new value that it found, to our y variable. So it makes our bullet move up the screen. Remember, negative values move up the screen because 0, 0 is in the corner. Remember to save your file. You can then close it or you can leave it open, it doesn't really matter. And we'll go back to our other AS file. So now this should make more sense. Our constructor here takes in 2 arguments. Remember, they're called parameters over here in the class. These are parameters here. But when we call our constructor, they're called arguments. We're sending in 2 arguments. We'll send in where our player's x value is and where our player's y value is, so that when we set the x and y value of our bullet, it'll equal where our player is. Okay. Remember that we have to push our new bullet into our vector. So then we can keep track of these bullets and we can test if they're hitting our enemies. And then, importantly, we need to add our bullet to the screen. So we'll say stage to add child bullet. The event listener is fired. It calls the shoot function and it makes our bullet go up. Now you guys have not written your test to see if the bullets are actually hitting the enemies. So my enemies are disappearing, but your enemies should not be disappearing at this point. Let's go to our onEnterFrame event. Remember that this function is fired 24 times a second every time a new frame is entered. We're going to make a function called moveBullets. So we'll write the function name followed by parentheses. Now let's write that function. Remember to write your function to start it outside of any other curly brackets. We'll call it public function. We'll call our function moveBullets. Our moveBullets function is going to have no parameters and return type of void, meaning it returns nothing. Let's look at our function. It just has a couple of lines in it. Here's a for each loop. For each loops were specially built to work with vectors. They're very readable. You can say for each variable bool. Name your variable anything other than something with a capital letter. It is a variable name of type bullet in our bullets. This is our bullets vector. So we use that variable name inside of our for loop. We'll say for every object, so this iterates through all the objects in our vector and does the same thing for everyone. For every bullet object, it has that bullet object call a function called move up a bit, with no parameter or no arguments are given to this function. Remember that this is the function that we wrote in our bullet class, the move up a bit function. So whatever object is calling this function, that object's y value will decrease by 7.5 pixels. So you can see how this function's working. It's going through every object. So this function's executed 24 times a second. And for every object in our vector, called bullets, so every bullet object, it gets to call that function and move up the screen a little bit. Its y value is decreased. This will allow our bullets to move up the screen. Now let's look at our other function, the check if hit enemy function. Again, we're going to add this function call to our onEnterFrame event function. So remember to add it to your onEnterFrame event function. So we'll call this function 24 times a second also. Now let's define this function. Function name is public function check if hit enemy. It's a function name, so we lowercase our function names. Followed by parentheses. Even if there is no parameters for our function, we still put the parentheses. And our return type is void. We have our opening curly bracket, and we have our closing curly bracket. We're going to have a lot of curly brackets inside of this function, so you might want to label them. Alright, so let's look at our function. We have a different type of for loop inside of this function. This is a more typical looking for loop. It looks like a lot of for loops in different programming languages. The beginning of our for loop. Notice our for loop has 3 parts to it separated by these semicolons. The first part of our for loop happens at the very beginning when we first create the for loop. It only happens one time. So this j variable of type number is created and is set to the value of 0. We're going to use this as an index into our vector. The second part of our for loop is the Boolean check. This Boolean check is checked at the beginning of every for loop. If it's true, then it lets us go into our for loop, execute our for loop. Here's the beginning of our for loop. Here's the end of our for loop. So this Boolean check checks to see if that variable j, our index j, who started at 0, is less than the length of our vector. Here's our enemy army, and notice he has an instance variable called to length. So this is the length of our vector. It's all of our enemy objects. Alright, and then the third part of our for loop happens at the end of our for loop. After our for loop ends, it comes back up here and it does whatever we have on this side of our semicolon, which is we increase that variable j by 1. Here's a second for loop. When we get for loops within each other, these types of for loops take a long time to execute. And that's because every time this for loop happens one time, this for loop completes itself. Here's our second for loop. Same type of setup for our for loop. Instead, we create a variable called I. We do not want to have the same variable names. Okay. It won't compile correctly and won't work correctly. So we create another variable for this second for loop called I, and we set it equal to 0. Our Boolean check, notice that we're going to go through all the indices in our bullets vector. So we say I less than the length of our bullets vector. And of course, the third part of our for loop, since we're going through and iterating through a vector, we just say I++ or add 1 to I. Inside of our for loop, we have an if statement. I guess we should be standardized and write this correctly. Alright. Here's our if statement. Our if statement is using a function of the movie clip class. So we have bullets I. We put a dot operator. Okay. The dot operator allows us to call functions of that class. Our bullets I is a movie clip. We see that it's a movie clip here. He extends from movie clip, meaning he is a movie clip, so he has access to all the movie clip functions. So this bullet can actually call this function that's been written for us called hitTestObject. The hitTestObject function tests whether it hits whatever's inside given as an argument. So we're going to give as an argument that enemy object. So an enemy object in our array. For every enemy object in our array, we're checking to see if it's touching or hitting every object in our bullet vector. If any two of our objects from either vector are hitting or touching each other, it'll make this if statement true. I've added a trace statement inside of my if statement so that I can see the values as it's hitting the objects on my console. It'd be interesting to see that. I put I've been hit, comma, and then an I, so what my index I is. So this I, remember, is our bullet, so the index of our bullet in our bullet vector. And then J is the index of our enemy army object. And then to get rid of our bullets and our enemy, there are many different ways that you could do this. But one way that won't give you any null object reference errors is to just move your bullets and your enemy objects off the screen. So I take my bullet object and I use the dot operator to access his x value. And I set his x value to -500, which in essence moves him way left of the screen. I do the same thing to my enemy, his x value. I move it to -1000, which moves it to the way left of the screen. Now, this isn't the most efficient way to program code, but will get us working for now. And if we want to remove them from the screen, a lot of code or code that we've written before, we would say stage dot remove child. And the reason that this will not work, or why it stops working after a while, is because of the way our stage is set up. The way that our stage is set up is that it has a display object list. And when it removes something from that display object list, all the other objects move in to take its place. And so these I's and J's and stages, they all start getting mixed up. And you start getting null object reference errors. Because it's trying to access an index inside of its stage where something has been removed already. So to solve that problem, we just move them to the way left of our screen. We won't get any null object reference errors. And in later videos, we'll go over a better way to take care of this problem, but this will get us working. So remember that you'll have to have an ending curly bracket for each of your opening curly brackets. So in this function here, you have 4 of them. All right, save your file, Command S or Control S. Test your file. Of course, always test. And now when you shoot your bullet, you can see it hit your enemy objects, and when that hit test is true, you can see that the console does print out the I, or the index of the enemy and the bullet that are hitting are touching. It does remove your enemies to the way left of your screen. So they do in fact disappear. In the next video we'll go over how to make an explode sequence for our enemy and how to call that sequence in our code. So we don't just have them disappear from the screen, we could have them also explode.